Hello and welcome back to Josh Does Math. In this video we're going to be finding the derivative of the function x minus 2 all to the fifth power. So normally if you were asked to find the derivative of this and you didn't know the chain rule, you would be stuck saying, okay, well I'm going to multiply all of this together, all of these x minus 2 terms, and that's going to give me one big polynomial. And then with that one big polynomial chain I can just use the power rule on each individual term and I'll get my final derivative expression. And you could do it that way, there's nothing stopping you except for the fact that it's just going to take forever. So instead of doing that, which takes forever, you can use the chain rule. And the chain rule says that the derivative of f with respect to g is equal to the derivative of g with respect to x. So if we can break this single function right here down into some composition of functions, we can use the chain rule. So sometimes you'll hear the chain rule said as derivative of outer function and derivative of inner function, where in this case outer function would be f, inner function would be g. That's what we want to do with the expression up here. And you can easily see that we could say, let's say u is equal to x minus 2. We can now write this as u to the fifth. So you see how the u just got combined, the x minus 2 just got combined into that single term u, and we say u to the fifth. It's a lot easier now, and we know, let's say we were taking the derivative of u to the fifth with respect to u. That's easy, that's just the power rule. Well, the chain rule says in order to get the derivative of the outer function with respect to x, you do derivative of outer function with respect to inner function times derivative of inner function with respect to, finally, x. So you can see that if you treat these differentials here as just plain old variables, you can see how you can say, oh, this cancels with this, and there, see, it's d of the outer with respect to x. But they don't quite cancel like that. That's just a helpful memorization tactic. But this is still a valid expression here to find the derivative of the whole equation with respect to x. And for u right here, we can put x minus 2 because that's what u is equal to. And this is now easy to solve. We use the power rule on u right here, and we get 5u to the fourth. The second expression here, take the derivative of that. So it's going to be the derivative of x with respect to x. Okay, that's just 1. Minus the derivative of u with respect to x. And okay, that's just 0. So we have 1 minus 0, which is just 1, and we're multiplying by 1, so nobody cares. We're left with 5u to the fourth. Okay, well, what was u again? Well, u is equal to x minus 2. Okay, so plug in x minus 2. And it's still to the fourth power. And that's our final expression. So you see how the chain rule may be a little bit more complicated to use, but in this case it saved us just so much time because we didn't need to do all of this distributing up here. Instead, we just used a more clever rule, and we can get done with the problem in at least half the time. So this is how you use the chain rule, and this is a common example where you would not need to use the chain rule, but where you would heavily want to use it because of just how much time it saves. So thanks for watching.